Hi friends, welcome to Ansel. So today it is the 76th episode in science series. So today in science it is physics. So today we're going to discuss about a very different category of physics, and that category of physics name is quantum physics. So quantum physics applies for everything at the size, at the fundamental scale of atoms, electrons, photons. Only they can be applicable. So just for those particles is quantum physics applicable. For us, quantum physics is not applicable. Yes, only standard physics like gravity or the laws of motion are mainly standard physics, and many other important things like motions like that. Okay, so first let's just start quantum physics. So any particle, any microparticle. So quantum physics also has separate classifications inside it, but we can discuss about that later. So normal physics. So wait, let's give an example. Not like this. Wait. Okay. So there is this very fast going ball. There's a wall here. Yes. Okay. This is a wall, and this is a ball which is moving here. Yes. So normally in standard physics, it will just bounce off and just go away. Yes. This is standard. And it only affects for this world, the world which we can see, and just for some like molecules and just like cells and those only. Not for like small particles, very small particles. Meanwhile, quantum physics, a thing known as quantum tunneling can happen. So this is the ball, or no, it's an electron, and this is some wall, like something. So if the wall is thin enough, then it can pass through. This, like let's take it as a photon. So this photon couldn't pass through this thing, anything. Let's just think that it is a small wall which was created out of Planck lengths. The Planck length, we're going to discuss about that later, but yeah. So this photons can literally pass through anything if it is thin enough. And not just photons, any small elementary particles like electrons, like those. Yes. So this is known as quantum tunneling. Yes. See, in this fundamental level, everything is different. Every major rule about physics is pretty much completely different. Yes. So teleportation. You may have think that teleportation is not possible up to now, but it is not for us at the quantum scales. So recently scientists have just done some experiments where there is some. Okay. So this is one small quantum particle, and this red one is another quantum particle, and suddenly they can exchange these both particles places. That means the red one goes here, meanwhile the blue one goes here. This is teleportation, but it is only applicable for the quantum world. Yes, so the quantum world, as said before, is pretty tiny. We can't see it. Yes. So there are many other major rules which are not applicable for us. Yes. And also one thing, they can time travel. Time traveling is also possible, kind of, at a very quantum scale. Yes. So some other tests happened, like, so there was another atom, small particle, an elementary particle. Yes. So this particle was going like this, and then they made it time travel back. So when it was time travel back, it was put back into here. But before it was time traveled, it was like here. Yes, time travel is possible. Yes. So let's just rub all of this. So first, how was even this quantum mechanics invented? Like quantum physics founded. Yes. So this was all founded by our trusty friend, not even doctor, but Albert Einstein. Yes. So this all came because one effect, the photoelectron effect. So take this as a metal, any metallic surface, and a wave of light, some waves of light hit it. Yes. So After the metal gets hit, some electrons will just escape the metal. Yes. So this is completely okay. But it will, so for example, so if the light waves have more frequency, more electrons will be sent out. Meanwhile, if it has a less frequency, less electrons will be sent out, which is practically wrong in standard physics, because more brighter, not more frequency, sends more electrons outside. So because of this, Albert Einstein started to study this, and finally he made up a formula and he got a Nobel Prize because of it. Great. But finally, the first quantum physics was invented, about frequencies. Yes. So this was the foundation of quantum physics. And one last thing that I need to explain about quantum physics, kind of parallel universes also exist. Yes. So first, I need to explain you another thing. So this is an atom. It's a small atom, pretty small. This is an electron. So this is, just take the hydrogen atom. It's just a normal nucleus made up of one proton and one electron. So for every atom, there's an electron zone, where an electron could be anywhere in that zone. For example, for the hydrogen atom, it is just a circle zone. Meanwhile, for any other atoms, it could be more complicated like that. Yes. So unlike in normal models, it does not rotate around the nucleus. That means the electron could be here, it could be here, it could be here, it could be here, anywhere inside the electron zone, orbiting this small thing, a very small thing. Yeah. So, but there's a theory that it's just one electron in different places at the same exact time. So all of this is just one electron, not separate electrons at the same place, at different places at the same time, the same point of time in existence. So that means, wait, let's just drop all of these others. Okay, so this is reality number 1. Next, this is reality number 2. And again, this can be reality number 3. See, it is different. All the places of the electrons are completely different. In reality number 1, it is here. Reality number 2, here. Reality number 3, down here. So this is all just a theory showing that there could be parallel universes at the exact same time. So Schrodinger's cat is, you may have heard of it. It is a cat which is half dead and half alive at the same time. But it's not like half dead or nor half alive. It's not half dead nor half alive, but fully dead and fully alive at the same moment of exact time. This is how these electrons also orbit around the nucleus. How these electrons are in the electron zone. Yeah, this is for today about quantum physics. It is just a simple version. There's still a lot more about quantum physics. Yes, so quantum physics is very important. It's so complex that normal computers can't process these quantum physics. Quantum computers only can. And they're even more powerful than supercomputers. The best computers we normally have other than these computers. And this quantum physics is so important, it could lead to many new revelations. Just like how the first nuclear bombs were invented like that. See you for today about quantum physics. Bye.